Hello all, as we continue our look at how to graph circular functions with horizontal translations. We will be using the same three circular function equations that we used when we were just finding the x-intercepts algebraically, so I've already pre-filled them in the data for the three graphs that we're going to do. But the rest of it will have a bit of a look at strategies on how to sketch, a couple different approaches that you can have, and then some good habits to try and build. So first off, the two things that we always want to look at is what's the amplitude, what's the period, what's the shape. So actually I should probably put in here, I've forgotten to do it, but whether it's reflected or not. Let's put it in, put reflected in just here. Okay, so straight away we can see the amplitude is 3, the period we'll come back to in a second, and then is it reflected? And the answer to this is yes, because we've got a negative sign there. And so let's even put in what the type of shape is, and so in this case it's a Cos graph. So straight off the bat, we know that we have cos like that, so this is just thinking about shape. And then if we then bring in the amplitude and reflections, so we'll just do some little sketch for that, we realize that it's reflected like that, and we also know that this is at -3 and the top up there is at +3. And then the last thing we can bring into this is then the period. Now the period isn't the 2, isn't this number here. Cos amplitude is 3. Yes, just putting in a different color to make it a little bit easier. But the period is equal to 2 pi on n, which is our 2 number, so it's 2 pi on 2, which is equal to not 2, it is equal to pi. So that, what we can also bring in now is the period and say, well, we know that if that starts at 0, that's at pi. And this is before we do any translations to it. What we can also see off here is h is equal to -pi on 2. So we can tell that that whole graph has just been shifted left pi on 2. So every coordinate on it, you could think about shifting it left pi on 2. So that then gives us, if we translate, we are going to get there we go. We're going to get something that looks like this. And as we showed in class, this is a fairly simple, because this midpoint here, before it's translated, well, we know that's half of the period, so that's at pi on 2. So we move that left, that's now at the 0 point. Our endpoint here, which was at pi -3, shifted left by half a pi, so we now get pi on 2, 3. So we're getting our endpoints in this example just by going through a process of geometric sort of reasoning, patterns of graphs. So this becomes -pi on 2, -3, and that was what, 0, +3. So we've got 90% of our work done right there, just by thinking about physically what's happening in the graph. So our endpoints, just for sake of time, I'm not going to actually write them in because we've already got them over here at the right, and our y-intercept, that's nice and quick. That's 0 and 3. Now, I talked about briefly in class, but I'll go over it again a bit clearer now, is how do we set up our grid? How do we set up our grid? So let's just we know it's going to roughly look like this picture here, so that's going to make life pretty easy. So I'm going to just put that there, is what intervals do we choose for our grid lines? Is it 1? Is it 2? Is it pi on 2? Is it pi on 3? What are we going to do? I talked about counting how many grid lines you have available. Okay, so in this case, let's not count the N2, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 this time because I haven't counted both the N ones. I have 14 grid lines available to me. And what you want to do is make your period a multiple of 4 grid lines. Okay. So in this case, I could choose to make 4 grid lines pi. Okay, and I'll be key here 4. I could make 8 grid lines equal to pi because that's a multiple of 4. So you could do 4, 8, 12, 16 grid lines is what you want to make your period. One of those, because that's going to make life a whole lot easier. So in this case, well, I can't fit 16, so I'm going to choose 12 grid lines to be the whole period. So I'm going to choose 12 grid lines is equal to pi. And from there, well, we can get 6 grid lines is going to be equivalent to pi on 2. So I can go count out 6. I can go 1, 2, 3, 4, 5, 6. That's going to be pi on 2. And I can go negative the same. 1, 2, 3, 4, 5, 6. And that's going to be negative pi on 2. And if I count those up, 12 grid lines gives me the period of pi. And that's going to just make it, and you'll see in the couple follow-up graphs that we're going to do, that's going to make life a bit easier. And the rest now is we have all the key information that we just got geometrically looking at what the transformations are. We can put in our key points. Pi on 12 there, that is pi on 2, negative 3, that's 0, 3, negative pi on 2, negative 3. And as we've looked at, the basic shape for all, if we just look at a single period, is that we've got our halfway point, which is the max, which we already have. We've got our minimum, but we also have what I guess we've been referring to as the quarter points that occur at the quarter and the 3/4 of the period. So, well, pi on 2, half of that is going to be pi on 4, and because we had 6 grid lines, we half the grid line, half that section again, from 0 to pi on 2, we halve that. That's going to be our 3rd grid line out of the 6. That's just going to be my pi on 4 point, and it comes through. Now, also we looked at in that previous video that I talked about, without even looking at grid lines, we could find these intercepts algebraically, which go back to the other video to look at how you could find them algebraically. So you could have just looked at this and gone, oh, well, negative pi on 2, half of that's negative pi on 4, so that's where my intercept needs to be. So we get negative pi on 4, 0, and we get pi on 4, 0. And there's my first graph done. And we're going to keep this routine going. Okay. So we've done the algebra in the previous video, like I said, to find the x-intercepts. Let me turn those. Oh, they've disappeared. Why are they not coming up? And they're not on that. Okay, I apologize. Let me go find what those were again. That was the intercepts were pi on 12, 5 pi on 12, and 9 pi on 12. They were the intercepts we found out for this one. Now let's go back and look at the actual function. Well, the amplitude is 4. Is it reflected? No. The period, well, that's going to be 2 pi on n, which is 2 pi on 3 in this case. We can't simplify it anymore. Now here's automatically, I guess, a little bit of a red flag. The period does not match up with our domain very well. It's not a perfect fit. Like in that first graph, it was just a nice perfect fit. One period filled up our whole domain. In this case, it's not quite, and we've got a period of 2 pi on 3, but then we're moving stuff by pi on 4. It's just a whole lot of nasty fractions. So this is where a little bit of geometric reasoning like I did up here at the top right will help, but it's not. It's going to give us an idea, but we're going to have to be really critical with like sort of picking grid lines and where to draw stuff. Okay, so we've got that now. Endpoints in this case, or let's do our geometric reasoning first. My apologies. So we know a basic sine graph looks like that for one period. Because it's not reflected, we can straight away put in our amplitude info that we know, which is 4 and -4. We figured out our period is 2 pi on 3. So we do know that it's going to keep going on for some amount. Okay. Up until some point when we hit pi, wherever that may be, it's probably going to be, we think about it, it's going to be about there, because half of 2 pi on 3 is going to be pi on 3, so that's our half point. So actually that's going to work out quite nicely. We think of this before translating, there is going to be 3 pi on 3, because we've got first period, halfway point is pi on 3, add that on to the 2 pi on 3, gets us 3 pi on 3, which is the end of our period. So we have that idea then, but we also know that this whole thing is now going to be shifted to pi on 4 to the left. We can see here that our h in this case is equal to negative pi on 4. So the whole graph is being shifted. Okay, that point there is now going to be negative pi on 4. This point here is going to be pi on 3. Take away pi on 4. If we think of the min and max, the quarter points, well, half of pi on 3, that's pi on 6. That first point there is now going to be pi on 6. Take away pi on 4. So every single like key point that we could find from that first top graph, like that intercept there, that's 2 pi on 3. Take away pi on 4. They've all been shifted to the left. The other thing we also need to take into account is the domain is actually from 0 to pi, so we're going to be losing that bit over there. We're going to be losing sort of that bit over there. And this is where having endpoints is really, really critical. You need to just sub in the ends of the domain into the equation to find out what your actual endpoint coordinates are. So we're trying to find that point there, and whatever maybe this point down there is, wherever it's cut off, it's not going to be very nice and neat. It's probably going to be a fraction or a decimal, who knows. But all you're going to do is substitute 0 into this whole equation, find your y value, substitute pi in, find it. So we do that quickly, put 0 in plus pi 4, we're going to get 4. Let's change colour so it stands out. We're going to get 4 sine, put 0 in, we're going to get sine of 3 pi on 4. And we'll put pi in, we're going to get pi plus pi on 4 is 5 pi on 4 plus 3 is 15. You get 4 of sine, 15 pi on 4, which is going to be, let's not put it in square brackets, sine of 3 pi on 4. 3 pi on 4 is there, sine of that, so that's pi on 4 in there. Right, that is root 2 on 2, but times by 4, so we get 4 by root 2 on 2. And 15 pi on 4, well, that's almost 16 pi on 4, which is the same as 4 pi, so that's around 1 to 2 pi, around, that's down out here. That's going to be negative root 2 on 2, so times by 4, so we get 4 by negative root 2 on 2. So we finally get our endpoints as 2 root 2, like I said, not nice, and negative 2 root 2 are our two endpoints. So that gives us a bit of an idea. Well, yeah, we are going to be positive up here, that zone, and then we're going to be negative down there in that one. Okay, y-intercept, well, that's just letting x equal 0, which we actually already found because that's one of our endpoints. So we also get a nice little bit of double up. Saves us a bit of work there. Okay, right. So we know our domain is 0 to pi, so I'm just going to offset my axes straight away. Over to the left here. Okay, and we're going to look at balancing now, going with that line of what are we going to make our grid lines? What interval are we going to make our grid lines? Well, we can see that we've got 2 pi on 3. That's a little bit annoying, but we've also got a domain of 0 to pi. So we need somewhere over here at the right, we need pi. But then we've got a period of 2 pi and 3, so we sort of want, we use that times by 4. So we need 2 pi on 3 to either be 4 grid lines, or we need to be 8 grid lines, or we need to be 12 grid lines, or we need to be 16 grid lines. You just want to make it a multiple of 4. We're not going to do 16 because we don't have enough. Do we have enough for 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We do have enough for 12, but that's only going to get us to 2 pi on 3. We need to go all the way to pi. So we're actually going to ignore that one as well. So let's just go with 8. So we're going to say 8 is 2 pi on 3. So 1, 2, 3, 4, 6, 7, 8. That there is 2 pi on 3. We're also going to go out another 4 grid lines to get us to pi. So 1, 2, 3, 4. So there is pi. So that's how we can use our period and our domain to come up with what we're going to set our grid lines. Okay, so let's fill in a little bit more info. That's going to be pi on 3. And now we're just going to, I guess, plot all our dots. We know we're going to go up to a max amplitude of 4 and a min amplitude of -4. We are, right, let's do our y-intercept. Well, 2 root 2, well, root 2 is like 1 point something, times 2, that's going to be, root 2 is 1.4. Yeah, I think so. Let me double check. Yeah, 1.41, so you double that, that's almost 3. So in there for scale, there's our y-intercept and our left in point, all taken up by one thing, so that's 0, 2 root 2. We need to put some, have I copied the right equation to get these intercepts? 4 sine 3x plus pi on 4. Yeah, pi on 12 is a really early intercept to have. The sine graph. Have I made a mistake? Let's continue on. We'll see if I've made a mistake somewhere, because this is what happens is you need to be looking and thinking, okay, is this working logically? With pi on 12s, well, we can convert all our grid lines from pi on 3s to pi on 12s by just multiplying. So that's going to be 4 pi on 12 there. This is going to be 8 pi on 12 there. And that's going to be 12 pi on 12. And because we've done those intervals of 4, it's also worked out really nicely that, well, 1, 2, 3, 4. So every interval's turned out to be pi on 12 using our scheme, which is really nice. So pi on 12, that means the first intercept technically is there. 5 pi on 12 is technically there. 9 pi on 12 is there. Our endpoint is supposed to be negative there, so that's pi comma negative 2 root 2. Okay, it is that's going to... Okay, so yeah, and this is where I was getting a little bit confused, is if we think about, let's think about this top point. We figured out before we translate, and we had our period of 2 pi on 3, before we translate it left, our top point, well, the halfway point is pi on 3, so our quarter point is pi on 6. So our local max is pi on 6. But if we do pi on 6, take away pi on 4, which is our translation, that's actually going to be a negative. That's just really quickly making them both 12, 2, take away 3. That's going to be negative pi on 12. So my little sketch here, I actually needed to shift it further and further left. So the graph is actually coming straight down because that maximum is over at the left. So the graph is actually something like that and coming back up. There we go. So this is, just thinking it logically about the points, maybe picking the first min or max and thinking, is it going to end up to the left or the right of the y-axis, is really good to help visualize. But we got our points, and between our intercepts is where, halfway between the intercepts is where the min and max is. So if I'm starting up here, it needs to come down, and then between those two, my max is going to be there. Between there and there, my max needs to be up the top. Same thing between, technically there'll be another point there, my max needs to be there. And now I just play connect the dot. Down, that, up, back around, back like that. There we go. So there's our graph. So there's a lot involved in that. There's a lot of thinking. There's a lot of sort of conceptual checking. Is, okay, how far has it moved left and right? What's that going to mean for this first maximum point? It turned out that it ended up to the left of the y-axis when my first little sort of sketch to help me, I had it to the right, and that was leading to a little bit of confusion. But we got there in the end, trusted our numbers, and played connect the dots. So let's do this last one, and I will come back to get the x-intercepts in a second. But amplitude, straight away we have a 5. The period is going to be equal to 2 pi on n. In this case it is 2, so we're going to get a period of pi. So let's put that in straight away. It's a regular Cos Graph, so regular Cos Graph looks like that. I'm not going to have to reflect it, so I can straight away start putting some info in. That's 5. That's negative 5. That's at 5 again. And my period, I found out, was pi. Okay. And then I need to think about what is happening with the translation. So I can see my h in this case is plus, it's positive pi on 3. So the whole graph is being shifted to the right, pi on 3. So all those key points, I go in, put them in. Period was pi, so my halfway point is pi on 2, my quarter point is pi on 4, my 3/4 point is 3 pi on 4. So if we think of all of those spots have been shifted pi on 3 to the right. Okay. Endpoints, we need to do a little bit of substitution. We need to substitute these two values into our function. So we're going to get 5 by, put negative pi in, oh geez, negative pi minus pi on 3 is cos of, that's negative 4 pi on 3 times by 2 is negative 8 pi on 3, and the other one is going to be 5 by cos of pi, take away pi on 3 is 2 pi on 3 times by 2 is 4 pi on 3. Okay, so I need to figure out what those two cos values are. So let's do a little unit circle. Negative 8 pi on 3, well, negative 6 pi on 3 is going all the way round. And then I'm going to go another negative. So yeah, doing a full loop is negative 6 pi on 3. So I need to go another 2 pi on 3, which brings me over here. That's going to be pi and 3 in there. Cos, I'm finding the horizontal component of that. That is going to be 5 by that's going to be by half, isn't it? Let me just draw in the first quadrant to make sure I'm getting this right. Pi on 6, pi on 4, pi on 3 is up there. It has the smallest horizontal component out of those three. Root 3 on 2, that's root 2 on 2. Root 2, which is just half. Yes, it is half. Okay, so that's that one. And then I need to do the 4 pi on 3, which 4 pi on 3 is, there's 3 pi on 3, so it's going to be down there. It's going to have the exact same horizontal component. So, and that was a negative half, I should have had in there for horizontal component. So that's going to be 5 by negative half again. So the y values for my endpoints at both sides, they happen to be exactly the same, is negative 5 on 2 and negative 5 on 2. At the far left and the far right. Y-intercepts I need to now sub-zero in, which is 5 cos of negative 2 pi on 3. Negative 2 pi on 3 is back around here, so it's the exact same thing. That is going to be 5 by negative half, so that's equal to negative 5 on 2. Okay, and x-intercepts, let me go grab them from the previous video. They were, oh geez, negative 11 pi on 12, negative 5 pi on 12, 1 pi on 12, 7 pi on 12. Okie dokie. Now we know our domain is from negative pi to pi. Our period is pi, so we've got this thing where we want our period to be a multiple of 4 grid lines. So pi can either be 4 grid lines, or it can be 8 grid lines, or it can be 12 grid lines. What are we going to do here? Well, to fit it in, what do we actually say we have if we use all of them? 1, 2, 3, 4, 5, 6, 10. 16. We do have 16, so we're going to use every single grid line here. We're going to use every single grid line. 1, 2, 3, 4. Oh yeah, that is the midpoint. Didn't look at before to me. Okay. So I'm going to put exactly in the middle as my midpoint. And I'm going to choose pi to be 8 grid lines just to make it all fit. So that's going to be pi over there. That's going to be negative pi there. And we've got negative pi on 2. Just putting in a couple reference ones that'll help me work. Now, we want to look at our numbers that we have above. We can see all our intercepts are in terms of pi on 12. So we may as well actually convert everything to pi on 12 to make finding those locations much quicker. So we get That's going to be 6 pi on 12. That's negative 6 pi on 12. Split that. That's going to be, there's negative 3 pi on 12. How have I clearly can't count. I seriously can't count grid lines. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. I've somehow, missed a grid line somewhere. Or counted one that didn't exist. Oh, I was counting the lines instead of the boxes. That's what's going on. So I'm just going to cheat a little bit. And imagine there is out there. So there we go. There's negative 12 pi on 12. Half of that. That's going to be negative 9 pi on 12. Okay. There we go. Now we just got to put in all our dots. So let's start with the y-intercept. That was negative 5 on 2, which is negative 2.5. So there. The endpoints were also down at negative 2.5. So there. We need to put in some intercepts. So 1 pi on 12. So if that's 3 pi on 12. And this is sometimes where it doesn't always work out really nicely. Because this grid line between 0 and 3 pi on 12, that's 1.5. But we can split it into thirds. So 1 pi on 12 is roughly about there. 5 pi on 12 is roughly about there. And I'm looking at the wrong thing. It needs to be 7 pi on 12. 7 pi on 12 is there. And negative 5 pi on 12, which is about there. And I need negative 11 pi on 12. So that's about there. Okay, it is very clear looking at this now, like thinking about what our shape needs to be. Think of this whole thing is moved to the right. So that means my max is clearly going to be over up here somewhere to the right. It's not over there. Or actually up at 5. We need 5 and we need negative 5. And it's going to be halfway between my intercepts. So I had intercept at 1 pi on 12 and 7 pi on 12. So I need to go halfway between those, which that's got a difference of 6. So halfway between those is 3. 1 plus 3 is 4. So there's 4 pi on 12 roughly there. So there's my max for that one. And that same pattern's going to repeat. The min will be halfway between that one there and that one there. Same thing, there's 6 pi on 12 between them. So we need to go 3 pi. So 3 pi on 12, there's 1, there's 2, there's 3. Out there. So there's that max, min I should say. And then add 1, 2, 3. The other max is up there. And the min far the right hand side one over this side. And that was at 7 pi on 12. Add 3 pi on 12 to it again, takes us to 10, which is there. So there's the other max. And now we've got all our dots in. It's just plain connect a dot. So let's maybe use purple. So we've got not that. Let's put horizontal lines at the mins and maxes to help with my shape. It's going to come down through that intercept there, back through that intercept up to there, back down like that, down, up, and back up. There we go. And then you should go in and actually label all those points. So where are we up to? Oh Jesus, long video. There's a lot involved. And this is also skipping actually how to find these intercepts algebraically. But yeah, I think having a good visualization of what the basic will look like, and in this case, I probably actually should have put the whole domain in and gone, well, it's going to have another repeat, and then that whole thing, that's at negative pi. And that whole thing between negative pi and pi shifted pi on through to the right, which if we look at our actual graph, that's what it is. The whole, if we look at these maximum points, they've been shifted to the right a bit. And we've lost a little bit off the ends and gained a little bit at the left. But there we go. Rewatch as much as you need to, pause and play as much as you need to. If you have any questions, please ask as always. And see you next class.